This is the homework for 661, 662, and 663. In problem 661, we need to set it up as a system of equations. We're given four equations, and we need to determine which one represents this scenario. So the fabulous footballers scored an incredible 55 points during last night's game. Interestingly, the number of field goals was one more than twice the number of touchdowns. The fabulous footballers earned 7 points for each touchdown and 3 points for each field goal. So we're going to create our let statements. We're going to let F equal the number of field goals and let T equal the number of touchdowns. What we know from the passage is that field goals equal 2 times the number of touchdowns plus 1, or 1 more than twice the number of touchdowns. So twice the number of touchdowns, so T represents touchdowns, so twice the number of touchdowns plus 1 more. So that's what field goals equal. We also know that you get 7 points for each touchdown. So it's 7 times the number of touchdowns. And you get 3 points for each field goal. So 3 points, 3 times however many field goals. And we know that the total number of points is 55. So we know the number of touchdowns plus the number of field goals will equal 55. So now we could set it up as a system of equations. We know one equation is that field goals equals twice the amount of touchdowns plus 1 more. And we also know that for each touchdown, you get 7 points, so 7 times the number of touchdowns plus 3 times the number of field goals equals 55. Setting this up into a system, we have F equals 2t plus 1. Well, if that's what F equals, we can plug it back or use the substitution method to input it into the bottom equation. And instead of 3 times F, we have 3 times 2t plus 1. And I'm going to put that in parentheses because we're multiplying everything that to F. And F equals 3t plus 1. So I put it in parentheses because we're multiplying 3 to each of these terms for what F equals. So now it's no longer 3 multiplied by F, it's 3 multiplied by the quantity of 2t plus 1. So now we're going to follow order of operations, and we need to do multiplication first. So we're going to distribute this 3 to both terms inside the parentheses. And so we have 3 multiplied by 2t equals 6t. 3 multiplied by 1 is 3. Now we can combine like terms. We have 7t plus 6t, which equals 13t. We still want to get t by itself. So inverse property of addition is subtraction. So we're going to subtract 3 from both sides. 0 pair. 55 minus 3 equals 52. Still don't have t by itself. So now inverse property multiplication is division. We're going to divide both sides by 13. This creates the giant 1. What you do to one side, you do to the other. 1 multiplied by t is t. 52 divided by 13 is 4. And now that we know how many touchdowns, remember t represents the number of touchdowns, we know that there's 4 touchdowns, but we need to determine how many field goals there are. And so we can plug t back into either of these equations, the top one or the bottom one. And to me, it makes more sense to plug it into the top one. It's a little easier than plugging it into the bottom one. And so we're going to plug our equation into F equals 2t plus 1. What does t equal? T equals 4. So we have 2, instead of t, we're going to plug in 4. So 2 times 4 is 8. 8 plus 1 equals 9. So we know that the number of field goals is 9. So the fabulous footballers made 4 touchdowns and 9 field goals. You always want to make sure that you plug back your solution into the both equations to make sure that it's correct. So if t equals 4, 2 times 4 is 8 plus 1 is 9. So that works, but make sure you plug it into both equations. If t is 4, 7 times 4 is 28, and then 3 times 9 is 27. 28 plus 27 equals 55. So it works for both equations. So for problem 662, you need to complete the table and graph the line that represents Micah's equation. So he lost some of the information, and the information that was given that he still had was the point on the graph, -3, 3, -3 on the x, 3 on the y. And you also had -2 and +1 in the table. So since you have the point on the graph, you could plug that into the table, -3, 3. And since you have these two, you can find the rate of change, difference of the y's over difference of the x's. So from 3 to 1, you're subtracting 2. 3 minus 2 is 1. 1 minus 2 is -1. And since we know it's a linear equation, it's a line, it has a constant rate of change. -1 and -2 is -3, and you can keep going. And the x's are increasing by 1. -3 plus 1 is -2. -2 plus 1 is -1. And you can continue to finish the table. So we know that the rate of change is, remember, difference of the y's over difference of the x equals the slope. So -2 over 1. So the slope equals -2 over 1, which simplifies to -2. The y-intercept, or the b value, is when x equals 0. So here's our y-intercept. So b equals -3. Now we can go ahead and take this information from the table and plot it on the graph. And so we have -2 on the x and +1 on the y. And you have to remember that the scaling of the graph is going by 1. So it's every box represents 2 units, 2, 4, 6. So halfway is 1 unit. And here we have the y-intercept, 0 on the x, -3, 1, 2, 3 on the y. And I went ahead and drew a line through my points. Part B, Micah thinks the equation for the graph could be 2x plus y equals -3. Well, our equation that we got up top, remember, is a linear expression, a linear function is y equals mx plus b. So we know that our slope is -2, and our b, when x is 0, is -3. So if we look at Micah's equation, if we put it in slope-intercept form, y equals mx plus b, get y by itself, we subtract 2x from both sides, and we get y equals -2x minus 3. So Micah's equation is correct. The other way you can determine if his equation is correct is to plug in values from the table into his equation. And if it holds true, then his equation is correct. So if we plug in 0, -3, the y-intercept, 0 for x, -3 for y, 2 times 0 is 0, 0 minus 3 does equal -3. So Micah's equation is correct. For problem 663, Given the sequence 2, 10, 50, 250, part A asks what kind of sequence is it? Well, you know it's increasing. So either you're multiplying or you're adding. And if I add 8 to 2, you get 10, but 10 plus 8 doesn't equal 50. So I know it's multiplying. So 2 times 5 is 10. 10 times 5 is 50. So it's increasing by multiplying by 5. So that is a geometric sequence. To find the 0th term, if you're multiplying to the right, when you work backwards, you're dividing by 5. 50 divided by 5 is 10. 10 divided by 5 is 2. 2 divided by 5 is 2/5. So that's how you find the 0th term. Part B, describe the shape of the graph. So if we were going to put these points on a graph, remember the 0th term would be 0, 2/5. This is the first term. Sequences always start with the first term. So the first term is 2, second term is 10, third term is 50, fourth term is 250. And you can see that it's not a line, this is a curve. So the shape of the graph is a curve. Part C, write an explicit equation for the sequence. Remember that the formula for a geometric sequence is T of n equals AB to the nth power. A represents the 0th term, B represents the multiplier, and n represents the nth term. So the 0th term is 2/5. The multiplier is 5 to the nth term. Now, if you were asked to find what would be the value of the 30th term, you would put 30 here and solve the equation for the 30th term.